Happy Friday. Today we're going to talk about the Advanced Scroll Temperature Protection, or better known as the ASTP. We talk about this quite a bit on the road. Brad and several of them were very nice and kind to bring me up on the history of this, the background before I started. This was introduced in 2004 on just the summer models only, specifically the 04J to be exact, but has since then proliferated into other models, and we'll talk a little bit more about that as we go along. For those of you that haven't been here before, my name is Don Gillis. I work in educational services underneath Ben Weiser. I've just been here just under 3 years this July in educational services, and I was in the field for about 25 years or so, somewhere thereabouts. I'm a licensed journeyman and so on and so forth. I wanted to bring this pie chart. It was actually recommended to me, and I was already thinking about putting it in there. So the reason I wanted to slide this pie chart in here, this is a pie chart on scrolls in general, not specific to the ASTP, okay? But here's what we find on compressor teardowns, especially with the scrolls with some of these internal devices, safety devices, whether they be temperature-driven or pressure-driven or whatever that might look like. When a technician like myself goes up to a compressor after it overheats, comes out with their voltmeter, checks it out, a lot of times they misdiagnose it with a failed compressor. As you know as well as I do, no one makes money on the warranties. So this is just a pie chart, and what I really want to point out to you is this. Obviously, this is mechanical. This is the electrical. Up here is your debris. That could be anything from dyes, flushes, or anything like that. And then this one, this 2% is on us, manufacturer nonconformities, okay? The one we're going to talk about today on this pie chart, the reason it's split in there, is what we call NFF, okay? This is the OEM side, and this is the service replacement side, okay? You can see they're slightly off. Sometimes this is a lot wider difference than it is today, but the moral of the story is this 30%. 30% of the compressors that come back on the scrolls, on the OEM or the service replacement side, is misdiagnosis as no failure found. In other words, we can take these compressors at the factory, which we do, fire them up, hook them back up, hook them up to electric and turn them on and actually run them with no fault found. It is misdiagnosed quite a bit in the field, and I can tell you from experience from being in the field, it's happened to me at least once or twice. It can happen to the best of them. So we just want to bring your attention to that and products like this, the components like this that are in the scroll compressor. And we talk about these things on the road quite a bit to let them know, let technicians know that they're out there, to be aware of them. And I slid a video in here that hopefully I can get to play and that brings a lot of light to how this works. Okay, the Advanced Scroll Temperature Protection, the goals are, it's a discharge temperature protection that is internal. It is automatic. It is reliable. On the internal side, the indirect contact with the key components, it's unable to be bypassed, which I think is key. Okay, anytime you can't bypass anything, that's huge as far as not letting the technician try to get by with bypassing something that could cause a catastrophic damage. It's automatic. There are no wires or relays or circuitry to manage. Very reliable, protects against all typical causes of scroll overheating. Okay. The Advanced Scroll Temperature Protection, cause of scroll overheating, system malfunctions, low suction pressures, no gas flow, heat not carried away, and missing or bypassed or poorly placed external protection devices, outside thermostat, things that should be there. On the system malfunctions, talking about fan failures, possibly a capacitor, loss of charge, blocked expansion devices, okay, which is very common, as you probably know. Low suction pressures, improper system charging would fall into that category. Out of the envelope operation, in other words, it wasn't designed to run there, okay? Bypassed or low pressure controls, again, bypassing controls that you shouldn't be. Missing and bypassed or poorly placed external, we're talking about external devices, inaccurate, internal temperatures, often much higher and temporarily bypassing devices that lead to damage. Initial damage results in failures later. Again, we're running outside that envelope. This is a close-up look at the advanced scroll temperature protection. Basically, this is a bimetal product. It reacts on temperature, okay? So in this diagram here, you can see where this is at. This is setting in the fixed scroll. There is a BAP line out here. Once this bimetal reacts and gets too hot, it goes up. This is it opening. It allows gas out of that underneath the floating seal. The floating seal drops. It's butted up against the muffler cap here. And once it drops, it allows this low suction pressure to enter into the compressor and lets the fixed scroll go up, and therefore disengaging the scroll set itself. This is the decal that you'll see on this. There's a couple different varieties depending on the age of the scroll. Again, this is just another blown up shot of that. Again, it's a bimetal underneath this floating seal. I like this picture here. The floating seal pops up. There's a bleed port here, by the way, that will make this floating seal go up on contact. Once it starts up, it starts unloaded. It sends that fixed scroll down 1 millimeter. This ASTP is right here in the fixed scroll. Again, it's a bimetal product. If it gets too hot, somewhere around, we're going to say later on 300 degrees, but if you do the homework on this, it's somewhere around 270 degrees is usually what we teach out in the field, somewhere thereabouts. And if you haven't noticed by now, something I learned in the short time I've been here, we talk about that 300 degrees where oil starts to break down. Almost every product that I've seen here that has to do with temperature hovers right around that 260, 270, 280 mark, trying to prevent that 300 temperature inside the compressor itself to break the oil down. This is just another close-up of the same diagram. Again, that bimetal down there blocking that passage. This is a passage, again, through that fixed scroll. Once it pops up, the bimetal reacts to the heat. It allows the gas to go out, and therefore the scroll set disengages. Let's see if I can get this to play. I ran a dry run yesterday with one of my coworkers to see if I could get to play the volume. The only way I could come up with it doing this was to actually put my phone up to my speaker. So wish me luck here.
Copeland Corporation, a division of Emerson Climate Technologies, is introducing advanced scroll temperature protection, a breakthrough development in internal discharge temperature protection on its 7 to 12 horsepower commercial scroll compressor platform. With advanced scroll temperature protection, the compressor's scroll elements actually unload, stopping compression when high temperatures are observed. The technology is completely internal, meaning there are no wires or sensors to deal with, and the device cannot be bypassed, a common cause of failure in compressors with external protection schemes. Advanced scroll temperature protection is made possible by the unique design of Copeland scrolls. In normal operation, compression forces try to push the upper and lower scroll elements apart. Copeland scrolls use a pressurized cavity on top of the upper scroll in order to provide just the right amount of hold-down force to keep the scrolls together. In compressors with advanced scroll temperature protection, a bypass hole has been added between this cavity and the suction side of the compressor. A bimetal snap-acting thermal disc blocks this opening, similar to a valve. When this disc senses excessive temperature, it snaps open and allows the pressure in the cavity to escape to the suction side of the compressor. As the cavity pressure drops, the hold-down force on the upper scroll is eliminated, allowing the scrolls to separate. This stops compression and allows internal temperatures to decrease, although the motor continues to run. In other words, the compressor will run, but will not compress gas, suction, and discharge pressures will balance. To reset the thermal disk, stop the compressor and allow it to cool thoroughly. If the compressor is allowed to run, heat will build up in the motor, causing the compressor to shut down on motor protection. Keep in mind that the longer the compressor is allowed to run unloaded, the longer it will need to cool in order to reset. If you find a compressor that is running but not pumping, it is likely that advanced scroll temperature protection has activated. Do not assume the compressor has failed. Turn off the compressor and allow it to cool thoroughly, which may take 1/2 to 2 hours. Then restart the compressor and verify that it is operating normally. In this example, watch as the internal temperature reaches 275 degrees Fahrenheit. The bimetal disc will snap open and the compressor will unload. Note that the pressures have balanced and the internal temperature is now decreasing. This unloaded condition will continue until the compressor is stopped and allowed to cool. Because it is internal, automatic, and cannot be bypassed, advanced scroll temperature protection will prevent compressor overheat failures that are often the result of system malfunctions, low suction pressures, or misapplied temperature protection systems. Remember, a compressor that is running but not pumping suggests a protected compressor, not a failed one. Look for the Advanced Scroll Temperature Protection label to determine if the system you're servicing has this internal protection technology. For more details, visit us on the web.
All right, very good. I think it's important to repeat what they said there at the end about a compressor running but not pumping is the sign of, let me see. There we go. Sorry about that. A compressor running and not pumping is a sign of something internally there, a safety device like this. Again, that 275 mark always being somewhere there hovered around or underneath that 300 degrees. So let's take a look at this. Advanced scroll temperature protection, what to do. If a protected compressor is identified, stop the compressor, allow it to cool thoroughly, restart, pump, and check for normal operation. Now, some of you, if you've been in the field before, I know one of my first service calls was not to do with this type of protection device, but I was told to run a water hose over a compressor to expedite the cooling process. And technicians know that. A lot of times supermarket people will pack bags of ice around them. That's what they do to cool the compressor down to try to speed that fact up. Do not assume a compressor running unloaded is a failure, okay? This is a nice little chart. Over on the left-hand side, we have recommended cooling times in minutes, okay? At the bottom, we have runtime minutes. So if it ran this long unloaded, you'll have to allow this side approximately to cool down. So for example, if we've got 40 minutes, it ran 40 minutes unloaded and got hot before you walked up on it, the store manager calls you and says, hey, something's not cooling right, or the building's not cool, whatever that looks like. You come out, it's been running for approximately 40 minutes unload, you diagnose the problem, you're looking at about a 60-minute cool time, thereabouts, somewhere thereabouts. The longer the compressor runs, obviously, unloaded, the longer it must cool before the bimetal disc resets, okay? Advanced temperature protection, likely situation when protection may activate. Number one, initial system charging or recharging after servicing. The compressor is run with too little of system charge. It's very common on split systems meaning that we have a condenser divided up from the evaporator somewhere. A residential AC would be a perfect example of that. This will result in a very low suction pressures, less than 25 psig on your gauges. And do not disable the low pressure cutouts while charging. Number two, field servicing. A system problem causing causes overheating. The technician will observe a balanced pressures, as we showed in that film. Risk of misdiagnosis is as a failed compressor. That goes back to that pie chart of the 30% NFF. Must stop, pump, and cool thoroughly and reset, as we just talked about. Depending on how long it ran is going to depend on the length of the time we have to let it cool. This just shows you a couple pictures of what the compressors look like with the decals. The ASTP is in various commercial scroll models that will be identified with a label on the compressor. Okay, these models are both active on the left-hand side. The Summit is the next generation. Some of the OEMs were use the ZP104 versus the ZP103, and the ZP122 were versus the Z120. We're attempting to have the OEMs use the ZP104, pardon me, versus the ZP103, and the ZP122 versus the 120. I apologize, I messed that up. However, they are both. There is no active plan to obsolete, though. They're still both in the field. This is just something I slid in there on the technical side. I wish I could have blew this up a little larger. This is an AE bulletin that I found, 1365, and basically, if you decide to hook a crankcase heater up there, it goes in great detail to tell you to connect the heater. So the connection point straddles the compressor seam weld, which is where it's welded at in the factory. I thought that was a neat little note. I think that's it for me. Before I end, I want to thank Brad Hess for letting me pick his brain on several, and also Sarah Taylor and Becky Holscher for putting this together for me to present. And I appreciate that. I'm not sure if there's any questions, Julie, or not.
We did have one question that came in regards to if this is used on ZB refrigeration models as well. And I was actually just messaging with one of our refrigeration engineers. His reply is that it's used on Summit models, which that's internal Emerson lingo. So I'm not entirely sure what frame sizes those are. I don't know if there's a sales manager out there that can help me out with what Summit means or what frame sizes. I've gone back to him and asked for clarification on that, or maybe Randy Tebby, not to put you on the spot, but Summit. Randy, do you happen to know what falls within Summit?
7 to 15 horsepower.
Oh. Okay. 7, yep, John, there we go. Thanks, John Dresser. 7 horsepower and up. So ZB, ZB refrigeration models also have ASTP on 7 horsepower and up. So were there any other questions out there? Or Brad, is there anything that you want to chime in on?
Yeah, please.
Brad, you're unmuted if there's anything you want to contribute
as
well.
I think, yeah, can you hear me?
Yes, we can hear you.
Yeah, so yeah, I think Dawn did a great job presenting that material. I really don't have anything else to add other than, there has been a lot of proliferation of these models, so there will be a lot more new products coming out with the new generation models, at least on the AC side, and the A2L models that are going to be in company that are going to have ASTP. So it's not just the Summit. We've been talking about the 715 ton. There's going to be some other models that are going to incorporate this technology also.
Yeah,
okay.
I think the easiest way to, and Mark Walczak just messaged me and said, just look for the bumper sticker, right? That's the easiest way to know that it has ASTP on it.
Exactly. It get really confusing if we trying to list all the models.
Everything.
So just look for the label. It may change a little bit over the years, but it'll still be there in the same location.
All right.
Great. Well, thank you. Thanks, Don. Very informative. Thank you, Brad, and the AC team for the content. I'm going to just for everybody's sake, I know I've sent out a lot of meeting notices, and it's probably overwhelming, not just getting them from me, and I know you're getting them from a lot of other vendors as well. For next week, I'm actually just going to send out one meeting notice that's a recurring meeting for each of the two. The training session, you'll get one meeting notice for all 5 days, and you get one meeting notice for the daily updates. And I'm going to try and list in there the topics for each day. That way I'm not bombarding you with meeting notices, and if you just accept them and add them to your calendar or put them as tentative, that's fine. I know that you guys are getting hit with a lot of content and a lot of requests. We talked about taking these sessions to less often, but frankly, we have a lot of content that we like to share with you, and we like building up the catalog of materials for you to use at a later time. So we're going to keep doing them every day. Dial in if you can. Our feelings aren't going to be hurt if you can't make it. We're always going to record the sessions and send them out. But hopefully changing up how I send out the meeting notices will not blow up your inbox when I eventually get those invitations out. So once again, thanks everybody for joining us. If you have any ideas for content, I can tell you for next week, let me just give you a brief highlight for what's coming next week. We're going to have Brian Beinasek back to talk about the product selection software, a little bit more in-depth on parallel racks. We're going to have an end user update from one of our kind of higher level guys on the OEM end user side of the business to give you some information on where Copeland's being specified, where we're seeing some wins. And we're going to have Rick Renda from the White Rogers Cooling Products talk about the EXD SH1 and 2. Those are 3 topics that are already scheduled for next week, and there's several others that I'm just trying to get slotted in there. So I will get that meeting notice out earlier so that you can share it with others. But, you know, frankly, whatever content you guys want to hear about, please let me know, and we'll get it scheduled. So thanks, everybody. Have a great weekend. Stay safe, and we'll talk to you on Monday. Bye-bye.
Bye.